All right, our next topic is going to be lenses. And lenses relate to refraction in that they are pieces of glass that allow light to be refracted through them. And as light travels through them, a light gets basically focused onto a single focal point. So we're going to talk about two types of lenses. We're going to talk about convex, also known as converging lenses. And we're also going to talk about diverging, also known as concave lenses. Okay. And these are called converging because as light enters, let's say from the left side, that light is going to get refracted such that these light rays are going to travel down, these are going to get refracted up, bent up, and this is just going to pass through, okay? And that's going to basically converge onto a single focal point on the right side of the lens. And that focal point will always have a positive value, okay? So it'll be positive focal point, versus a diverging lens. When light comes in, basically the rays get scattered out, and if you trace them back, you end up with a focal point on the left side, which always has a negative value, okay? So if you go ahead and grab your phys guide, that looks like this, okay? And we're just going to kind of walk through real quick just some properties of these kinds of lenses and what's positive and what's negative and the terminology and all that kind of stuff. So first we have a converging lens. As you can see, we've got the focal point is always on the right side. It always has a positive value, okay? Always has a positive value. And your object, I'm always going to draw, and you're probably always going to see, doesn't really matter, but the object drawn on the left side. And images for these can actually form on either side, and we'll talk about how to remember when where the different types of images form, but we'll get to that in just a second. So this would be our object. This would be the height of our object, okay? Over here would be our image, and this would be the height of our image. Anytime something's located above the principal axis, this is the principal axis. Anytime anything is located above it, basically that height is going to be given a positive value. And anytime an object is located below it, it'll always be inverted and it'll always have a negative value. So say like -2 centimeters for that height, okay? So you've got the focal point and then the center of curvature. The center of curvature, okay, is always equal to basically 2 times the focal length. So if you take the center of curvature divided by 2, then that'll always give you your focal length. Okay, and those equations can be seen over here. Okay, you have the object distance, which I'm going to stick with the notation that is going to be on your AP worksheet, which is S sub 0 or S sub O for the object distance. That's going to be your object distance. And then the image distance is S sub I. Image distance. Okay. All right. So when images form on the right side of a lens, this is the real side. So real images form here. Okay, real images are images that you see through the lens. So a magnifying glass is a convex converging lens, and you can see the object on this side of it. So this is your eyeball, and you're looking through it, and it's magnifying it on this side, and that's going to produce a real image. Virtual images for lenses are produced on the left side of your lens. So you'll have sometimes, and we'll get to the ray diagrams in a minute, but you can have images that are produced from your object, images that are produced on the left side of the lens. Virtual images can be projected onto a sheet of paper. Okay, you can't actually see virtual images inside of the lens like you can a real image, but you can project those onto a sheet of paper. And we'll get into the difference between real and virtual in really at the next, probably when we talk about mirrors. So real images, see this is the real side of the lens right here. Any kind of image that's over here is going to have a positive image distance. So this distance here is always going to be a positive value if it's on this side. If it's on this side, it's going to have, the virtual side, it's going to have a negative value for the distance. And that's always the case for mirrors or lenses. So real images always have positive image distances, okay? Virtual images, okay, always have negative negative image distances. Negative image distances for virtual images. Okay, I know this is a little overwhelming, but we'll do a lot of practice with this too. Okay, all right, so that's convex, and we'll talk about the different types of images that can form and all sorts of things in just a second. Then you have diverging lenses. These are lenses that cause a light to scatter, and they always form the same kind of image, and we'll talk about that in just a minute, but they always form the same kind, and it's the same kind of thing. The thing is, of the focal length, up here the focal length is always positive and it's always on the right side of the lens. Down here for diverging, the focal length is always on this side, okay, and it always has a negative value, okay. So the focal length for a diverging lens is always negative. Same thing, virtual's on this side, real's on this side. So if you have an image that forms on the virtual side, it's always going to have a negative value, okay, in terms of its distance. This will be a negative distance to the image because it's virtual, okay. All right, here's some of our important lens equations, okay. Basically, this is a very, very crucial one. The way that it's written on your equation sheet is 1 over F is equal to 1 over SO plus 1 over SI. And I'm going to write it like that pretty much on all the problems I give you because that's how it's written on the AP equation sheet you have. And you can relate the image height and object height to the distance. So we're going to call this SI and SO. It's positive, sorry. It's positive. So negative SI over SO. And magnification. Okay, magnification. And we'll talk more about that in just a second about what that means. So if you get a magnification of, say, let's say I get a magnification of positive 0.25, okay? Anytime your magnification, if it's less than 1, that means your object is going to be, your image is going to be reduced. It's going to be smaller. This positive value right here means that the image is upright, which means that it's above the principal axis. It's on top of the principal axis, above principal axis, okay? Let's say I got a magnification of negative 2.5. That means my image is enlarged. And that negative sign means that it's below the principal axis and inverted. Okay, so let me just clarify really quick, okay? For magnification, positive value means it's upright and it's above the principal axis. A negative value means that it's inverted. All images below the principal axis are inverted. So it's below the principal axis, okay? In terms of your distances, say to your image, okay, so the distance to the image, if you get a positive value, that means that it's real. And for lenses, that means that it's on the right side of the lens. If you get a negative value, that means it's virtual. Okay, so it's going to be, in this case, it's going to be on the left side of the lens. Okay. All right, let's look at our ray diagrams. If you could pull those out, please. Let's start with our converging. Let's start with converging. Okay. And we're going to trace these together. So if you haven't already, go make sure you have a ruler and probably a pencil, okay? Because we want to figure out how we know where these objects are located, okay? How we know where they're located. So there's two main principal rays that I want you to learn for lenses, okay? Two two main principal rays. And for lenses, the two principal rays, in order to know where your lens is, are going to be parallel to focus, or to your focal point, and center of lens. Okay, those are going to be your two principal rays in which you can find any image. Okay, any image at all. Okay, so what we're going to do is I'm going to take my trusty meter stick, because I don't own a ruler at my house. Don't ask me why I have a meter stick though. All right, we're going to line this up, and from our object, the tip of our object, we're going to draw a line from parallel, and the second you hit the mirror, okay, the second you hit the mirror, you go parallel through the focal point, which, remember, for convex mirror lenses, those are on this side. This is the focal point right here. All right, so parallel to focus. That's not a very straight line, sorry. And then through center of lens. So you're going to go from the object through the center of the lens, which is about, this thing's unruly. No pun intended. That was supposed to go through the center. As you can see, I went through the center. The point at which these two lines converge, that's where your image forms. And remember, if it forms below, it's always inverted. Okay? So our image in this case is going to be inverted. Remember, this is the virtual side, this is the real side. Real. Okay? And it's going to be reduced. Okay? Or smaller. We'll just say smaller. Reduced or smaller. Okay? As you can see, this object is beyond the center of curvature. So beyond the center of curvature, we're going to remember a little acronym here. SIR. S-I-R. Smaller, inverted, and real. Okay, smaller, inverted, and real. That's how we're going to remember what the properties of that image are. Properties of the image. Smaller, inverted, real. All right, now at the center of curvature, once again, we're going to draw our line parallel to focus. So we're going to draw a line parallel to the principal axis. And then the second it hits the lens, we're going to go through the focus. Parallel to focus. And then our second principal ray is from our object through the center of the lens. And this is supposed to hit here. So I didn't draw my line very straight. Okay. All right. As you can see, these are the same size. Okay. So anytime you have an object that's the same, it's going to be the same size. Real. Same size, real, and that was my dog. And inverted. Okay. All right, for the third one, we've got between the center of curvature and the focal point. Same thing, guys, not changing anything. We're going to go parallel to focus. So parallel to focus. And then through center of lens. And so we're going to go center of lens. As you can see, that object is going to be inverted, larger, and real. So the acronym we're going to use to remember that is LIR, L-I-R. So whenever you have an image formed with an object that's between the center of curvature and the focal point, it's going to be larger. The image is going to be larger, inverted, and real. These are the image properties. Okay, larger, inverted, and real. All right. Flip over the page, or I think it might be on the next page for you guys, on the next side. Got 2 left. So the properties of the image when it's at the focal point, this one's kind of fun. So we're going to go, once again, guys, we're going to go parallel to focus, center of curvature, through the center of the lens. Okay, as you can see, these lines run parallel. Okay, there is no point at which they're going to converge. And so anytime you have an image, anytime you have an object at the focal point, no image forms. Okay, no image forms, because as you can see, those lines are parallel. And same thing here. We're going to go parallel to focus, and then through the center, if I can get. Now, you can see that these lines are diverging. So in order to find the image, you have to find the point at which that they're going to converge. So what you need to do is we're going to trace this out basically on the virtual side, which remember is over here, virtual, real. And we're going to see the point at which they converge, okay, which is going to happen right here. Okay. So this image is larger, upright, and virtual. So the acronym we're going to use to remember it, anytime you have an object between the focal point and the lens, it's going to be LUV, love. Larger, upright, and virtual. Larger, upright, and virtual. So for convex mirrors, easy way to remember this, guys, anytime you have an object, if you have an object basically beyond the center of curvature, the image, this is beyond the image formed, will have these properties. SIR, S-I-R, smaller, inverted, and real. Smaller, inverted, and real. If it's between your center of curvature and your focal point, it's LUR, larger, inverted, and real. Larger, inverted, and real. And if it's between the focal point and the lens, it's larger, upright, and virtual. SIR, LUR, love. Okay, SIR, LUR, love. That's how you're going to remember that. Those are the different properties that they have. Okay. All right, that's convex. Let's go to concave. Pull out your concave worksheet. I know this says mirror at the top. It should say lens. I don't know why it's wrong. All right, the important thing to remember with this, guys, with diverging, the important thing you've got to remember is that the focal point is always negative and it's always on this side. This is your focal point right here, not this. You're going to pretend like these don't even exist over here. Okay, this is your focal point. It always has negative value, but you're going to use the same principal rays. Okay, parallel to focus and center of lens. Okay, so let's do that. Parallel That doesn't look very parallel. Sorry. To focus, try to use a meter stick. I really need a ruler right now, but that's okay. So parallel to focus. And then through the center of the lens. So the point at which those lines converge is right here. See how tiny that little image is? Okay, that's your image right there. And SUV, SUV, is going to be the way that you remember that. So, SIR, LUR, love, and SUV. Smaller, upright, and virtual. Smaller, upright, and virtual. The cool thing about these lenses, guys, is that they all have the same image. All of them. All of them, all of them. Okay? So look. parallel to focus, center of lens, same thing, same thing, see, same image, okay? So I want you guys to do that all the way for all of them. They're going to have to produce the same image, parallel to focus, center of lens, smaller, upright, and virtual. Remember, this is the virtual side, this is the real side. Okay? And same thing for the ones on the back, guys. Let me do this quick. Parallel to focus, center of lens. You can see there's the image right there. And same thing here. Parallel to focus, center of lens, image is right there. It's always going to be inverted. Always going to be, I'm sorry, it's always upright, always smaller, always virtual. Okay? So, if we go back here, these are for convex and for concave. Always, oops, sorry, have the same image properties. Sur, lure, love, and sub. Okay?